This is something you've probably done before, but I want to review it with you because I think in some of your cases, we're still struggling a little bit with graphing, okay? And when we covered linear inequalities, graphing linear inequalities back in chapter 2, we went through it really quickly. And so let's go through it. We'll go a step at a time. And for those of you who feel very skilled at this, you're going to feel insulted because we're going so slow, but you'll be fine, okay? Now, the difference between solving a linear inequality and solving a system of linear inequalities is that we're going to have multiple graphs on one grid, similar to what we did when solving systems of inequalities solving systems of equations by graphing. Okay, we had two lines, we saw where they crossed, moved on from there, okay? We'll get to the specifics here in a second. If you would like to take a picture of this screen, please do so. You can also, actually, there's not a video for this one quite yet. So take a picture of this one. Now, this is a pretty simple system of inequalities. They won't always be this simple. Sometimes the inequality, will not be in slope-intercept form, but for the purposes of time, saving time and giving you more time to work, we'll make this pretty simple, okay? So here's the general idea, right? Because when we graph a system of inequalities, we're graphing two separate linear inequalities, and when we graph linear inequalities, you have to shade, because there's a region of points that satisfy that inequality, as opposed to a system of equations where there's usually only one point, okay? So we'll start with, first one. I'm going to make it red so we can kind of tell, all right? Since it's already in slope-intercept form, we need to start with the y-intercept. What is the y-intercept for this first equation? 4. So b is 4. And so you graph that first, okay? Graph that y-intercept first. What is the slope for the first inequality? -2. Yeah, let's get -2/1 because we're going to have to make a vertical move and a horizontal move. So from here, I'm going to go down 2 to the right 1, and I'll have a point. What do we also have to look out for when we draw lines for inequalities?
Dotted or solid.
Dotted or solid. Is this one dotted or solid? Dotted. How do we tell?
It's not equal to.
Correct. There's no or equal to here, so this one has to be dotted. Now let's talk that for a minute. Why do we make it dotted? What it's saying is any point on this line will not satisfy this. Okay? So, I mean, we have a point here, 1, 2. If I plug 1 in, y is 2. So this side becomes 2, this side becomes 2. 2 is not greater than 2. So all the points on this line do not satisfy that. If it had the or equal to, then we'd be fine. It's either greater than or equal to, and then it would be fine. So that's why it's dotted. Now, something that we went over very quickly back in chapter 2, but I want to reinforce with you. And some of you need to pay attention to this, okay? You can test a point, and you can plug 0, 0 in and all that good stuff. But when it's in slope-intercept form, you don't have to do any of that. Greater than means shade above it. Well, where is above this line? That's going to be here, okay? Now, so your shaded region is going to kind of look like that. Now, I did it really sloppy, and you're going to see why in a second. Okay, what you have to be able to understand is that it's above it. Okay? And then that one is done. Okay, so then we're going to move on to the next one. Any questions before we move on to the next one? Anybody want to take a guess what color I'm going to use? Blue. You guys are so smart. I am going to use blue. You are correct. All right, so we start the same way. What's the y-intercept? -2. Okay, so then I plot that. What's the slope? Okay, so let's look here. Because some of you think the slope is 0. There's always a 1 in front of there. Okay, there's a 1. Understood 1. Imaginary 1. So I'm going to use slope as 1 over 1. So that means I'm going to go up 1, right 1, and I'm going to end up with a point right there. Okay. Solid or dotted?
Solid.
Okay. Or equal to, so it is solid. All right. Am I shading above or below the line? How do you know? Less than, below. Okay, less than, below. So I'm shading down here.
I always learned though they're supposed to plug in zeros.
Yeah.
You can. You can.
Look at the sign.
Yes, that's what I'm telling you. Why not just, I'm telling you. If it's in slope-intercept form, there's no reason to go crazy like that. Could you plug in 0, 0? Sure. Then this says 0 is less than -2, which is false.
Yeah, so you'd be below.
And so then you below. But look, if it's in slope-intercept form, less than or equal to is below the line. Greater or greater than or equal to is above the line.
Only if it's in slope intercept form.
Correct, if it's in slope-intercept form. Now, one of the things that I do know about you guys, having spent a little time with you now, a lot of you really only graph from slope-intercept form. And you take the equation, or in this case, inequality, and you will rearrange it into slope-intercept form, and that's where you're comfortable graphing, which is great. If that works for you, I'm fine with that. You don't have to do it that way. You know, I've taught you other ways to find slope and y-intercept, right? If it was in standard form, the y-intercept is c over b, and the slope is negative a over b. You could do that. You can make a table of values. Again, this is one of the nice things, okay? And we talk about this a lot in math, but there's an art to it. You have different preferences. I don't care which form of art you want to use, because in the end, we all got to get to the same place, and that answer is the answer. Okay? Now, you can do it like this. The thing that I want, the concept that and how this is connected to systems of equations is, in systems of equations, we talked about a point of intersection. In systems of inequalities, we're talking about an area of intersection. So obviously, we have red and blue coming together, making what color? Purple, thank you. Okay. And so the actual area there, the solution is what's over there in purple. Now, I'm going to, one of the things I want you to get good at eventually, maybe not today, today might not be the day, but I want it to happen soon, is I want you to make your graphs less messy. And what I mean by that is here I put the red in, I put the blue in, and then I first just do your initial shadings lightly, and then really darken in the region where you want me to focus my attention, okay? That's another way to do that. But like I said, I see this, okay? And I want to see you be able to do that without erasing, right? Because what I want you to be able to do is get to a place where you just get this, okay? So in your mind, what you're thinking is, okay, this is above, this one's below, where did both of those meet? Okay? And so eventually where I want you to get to is something like this. Now, let's be clear what's happening and what the solution is. The graph is the solution. Okay? The graph is the solution. Every single point over here will you'll get a true statement out of both of them. So for example, if I plugged 10, 2 in, right? So this would be 2, negative 20 plus 4, that's negative 16. 2 is greater than negative 16. That's true. If I plugged it in here, this would be 2. 2 is less than or equal to 10 minus 2, which is 8, which is also true. Every single point in this region and the points on the blue line, not on the red line, will satisfy both inequalities. Now, I'm going to put something up here that just as an identifier, you don't have to write this in, but just so you actually want you to get to here, where that's all we see. Clear? This is what's known as the solution region. You don't have to write that in. You don't have to put that on your homework. You don't have to put that on the test. I'm just pointing that out to you. all the points in that region will satisfy both inequalities. So that's how it's connected to our systems of equations. Because generally speaking, with systems of equations, we end up with a point as a solution, a point of intersection. For systems of inequalities, we have a region of intersection. Okay? This is saying any point in the solution region will be true for both inequalities. I'm just going to remove that because we don't have to label it. That's just that's the understanding that I want you to have. And that's how it's connected. Okay. Questions about any of that? My guess is you knew how to do this and you knew what to do before, but maybe you didn't really understand what it stood for, what it meant, what it was representing. Okay, so we should be able to get that deeper level of understanding. Now, I want to backtrack off something that I said earlier. I want you to get to here, because think about on your test, right? When we have our test, you're going to have to do it in pencil. All right, so it's not as easy to erase your shading kind of thing. If you want to do it this way, that's where we want to go to. That's where we're sort of at a more expert level there, okay? Now, there's a couple other things I want to talk about, and then we'll be done. Because when we talk about graphing, we can have some strange situations that happen too that won't always be like this, all right? Sometimes we can get parallel lines. Okay, we can get parallel lines. Now, the thing that's important to understand is that the graph is always the solution. Yeah, you just set my desk and you put that. Yeah. The graph is the solution. We don't have to state, any no solution or infinite or anything like that. You don't have to do that. Okay. For systems of inequalities, the graph is the solution. There's no reason to state no solution. Just present the graph with the shading and you're good. Because what will happen with parallel lines, you have one of two situations. You're shading in between the parallel lines, sort of filling it in, or you're shading on the outsides of those parallel lines. Okay? You are not required to make a conclusion based off the graph that you see when you have parallel lines. Just do the graph, do your shading, and move on, okay? And then you're good to go. Because you still have to show the shading, regardless.